Now I'm going to run the frequency. I'm going to run the frequency from 2 gigahertz to 3 gigahertz with the linear spacing of 101. So I'm going to create 101 points, which is spaced over 2E9 to 3E9. 2E9 is 2 gigahertz, 3E9 is 3 gigahertz. And I'm setting the input and output port. So the circuit set ports 2, 1. So the input is between 2 and 1. The output is between 6 and 1. So see here, I'm setting the input and output ports 2, 1, 6, 1. And I'm calculating the S parameters of circuit, frequency. You know S parameters. I hope you have the idea of S parameters. S parameters are used for high frequency analysis. For low frequency, you have Z parameter, Y parameter, ABCD parameter, and you have H parameter. But when you go to high frequency, because of skin effect, the voltage and current measurements become very difficult. So you can measure only the power. So you will measure the incident power, you will measure the reflected power. That gives rise to what is called as reflection coefficient. The S parameters is based on reflection and transmission only. So you send some signal, how much is transmitted, how much is reflected from the input side. Same way at the output side, how much is transmitted, how much is reflected. That is output side. Okay. So whenever we are going to deal with high frequency analysis, we are naturally going to do only S parameter. Okay, we are going to do only S parameters. So now I am going to convert the S parameter into transfer function. I'm going to fit a transfer function to the circuit. So see, everything is simple in MATLAB. You have to derive it in pages to create the transfer function. When you do it theoretically, you have to convert everything to Laplace domain. You have to do KVL, KCL, write the loop equation, find the output by input. Then you have to do the transfer function. But in MATLAB, you see everything is pakka. You just need to use the command S to TF. S to TF means convert the S parameter object into transfer function object. And finally, you see, I am going to uh, I'm going to plot the graph. I'm going to plot the graph. So what they are doing is they are fitting the transfer function to a fit polynomial, and they are going to plot the actual response and the response of the polynomial, and they find that both are going to be approximately same. So we will just run each section. So this is section 1 I'm running. So it is initializing my circuit. Okay. Now section 2 I'm running. You know, when you are going to use live script, you have to run each section. Section 3, section 4, now section 5. Section 5 only you will have the figure window. Some errors, so just commenting it.